Hey, what's up? Can you hear me? You're real quiet.
Can you hear me better?
Okay, yeah, it's better.
Anyway, anyone going to join us?
Man, looks like it's just us again.
I'm on East Coast time, so it's pretty late.
Oh, do you live over there?
No, I'm just visiting.
Oh, okay.
For a little bit, so tired. I was about to go to bed and I remembered we had this. It's like, oh no.
Yeah. I mean, I think Ampersand, he hosts the CS2B on Monday at 6 p.m. as well, right? And I think he says we're pretty much free to join that as well.
Oh, really? Okay, maybe I'll
Yeah.
do that then.
I think that's what some people are actually doing and not coming to this one.
Interesting. Hey guys.
Hello.
Hello.
Hey.
How's everyone?
Hello.
Hey guys. We were just wondering whether people were going to show up.
What's the total number of people in our class? Does anyone know?
I think it's pretty low.
Yeah,
Like 4 low?
Probably like 8.
I think
Okay.
like it's unlikely that the session will get canceled, but it's up there.
Yeah.
Well, they wouldn't cancel it by now, right? We're already like 3 weeks in.
Yeah, I think so. Maybe like that's why it's not lessons, but we're still good.
Great.
Yeah. Did you guys finish quest 3 yet?
Yes.
I haven't finished quest 2 yet.
I am finishing it up. I think I'm about to get through to the password tonight. I actually had an issue with like my sparse matrix class. I guess quest 2, it lets you get through to the next quest. It gives you the password with like a more lax implementation of the set method. Because I was getting a lot of bugs like missed pointers and broken pointers and stuff. So like I think I found the issue. It was like with my setting the default values. So I fixed that, and then now I'm getting like my matrix multiplication is working. So I gotta, and then you gotta figure out how to optimize it a bit, right?
Are we allowed to talk about algorithms? Like not sure code, but like just talk about the algorithm.
Yeah, I'm pretty sure we can.
That feels right.
Okay. Yeah, I'm not able to get past the small tests. Like I did a lot of different things. Like at first I was iterating over all the rows and columns, which obviously doesn't work. So I see ones, right? But that still doesn't work. So like I skip over all the empty rows and I don't iterate further if the current column is a default value. I'm still not able to pass the test case. So then what I did is that I tried implementing everything as a matrix so that I don't have to keep calling .get each time. I just do it
Right.
directly. But that doesn't work. So I don't know what to do from there.
How are you implementing it as a matrix?
Like I just copy over in n squared time all of the stuff from the sparse matrix to some other auxiliary matrix.
Yeah, basically you just
Okay.
construct the matrix with the sparse matrix data, right?
Yeah.
Oh, I see. That's like
yeah, because you could get the constant axis now once you put it into a vector of vectors, right?
Yeah.
Yeah.
And I was hoping that would kind of speed it up because honestly, without that, it's kind of O of n to the power 4, like worst case, you know. But then it kind of removes that n multiplier because you're just getting everything in constant time.
It would get everything in constant time once you copy it over, but I think copying it over is the very expensive like capital that you have to invest in. And I think that action in itself would probably go over the test time case.
I'm
'Cause
not
if you're
sure.
like he's testing with like a 2600 by 2600 matrix, and if you're copying that, especially like if it's just like default values, then it's just like you're
Hmm.
copying over a lot of like it's expensive to copy over, and it's not worth it because you're copying over mostly like zeros for the most part.
Right. But then I guess then the question is like, maybe then like you don't copy anything except the ones that are non-defaults.
Except yeah, unique values.
So unique values. Yeah, maybe that would work. No, but actually, no. You
But
have
then
to
you need
iterate
a way
through
to represent the columns.
Yeah. Mm. Well, something else I wanted to try, and like I tried, but I couldn't get it implemented, was using like some kind of map that like stored all of the columns to like a vector of all of the rows that work with that one column. So you don't have to iterate over every single row and like skip over columns. Instead, you iterate over all the columns that are non-default.
I think that's kind of like what Justin made a post about, right? Like creating like a vector pair of the rows or something like that. I think he made a post something like that.
Mm.
But I mean, and then Shreyas, when you put it into a vector, like you gotta implement it and working. It just still didn't pass the test case. It still wasn't
Oh,
fast enough.
actually, there was an issue in the sense that when you, I mean, like I can think of a way to get it to work, but I don't think that's the correct way to do it because, like, let's say you have these columns, right? The thing is that the columns aren't going like 1, 2, 3, 4, 5 consecutively. It can go from 2 to 15 to 16. And so in the other matrix, you also have to skip from the second row to like the 16th one to the 17th one. Like, and I didn't really know if that was the way you're supposed to do it. Because then you also had to change the way you multiply matrix. Because usually you find the row and then multiply all the columns. But in this case, you're finding the column and multiplying all the rows. So I don't know if that really made sense or not. Yeah. Like, I don't know if it was the correct answer. So.
So for each, like if you take, for instance, the first row, and if you're using iterators, then like you said, it's not going to necessarily be sequential. But just by using the iterators, you're going to skip over a bunch of default values. And then you're going to have the columns that are intrinsic to the node for each one. And then as you iterate through them, the way that matrix multiplication usually goes is that you want to find a corresponding, like you transpose it, and then you want to find a corresponding value in the column of B. But then, like you said, there may not necessarily be a corresponding value there. Otherwise, you would have to, you would now have to iterate through each row of B and then each column of B to see if like there's the same thing there. So what I found really helpful for me in trying to get past the last test case was using add to cell, that method that you have to implement before multiplying the sparse matrix. That's what I eventually used to pass the large matrices test case.
Okay. I'm a bit confused. Like, don't you have to use that method anyways? Like, how are you doing it before?
Before I was using, well, before, in order just to pass the small matrices test case, I was basically just using the same algorithm as the regular matrix multiplication. So it was just iterating through each column of A and then iterating through each row of B and then each column of B. Just doing like your regular like dot product to get the matrix. And kind of like you said, I was trying to pre-optimize by like for each row of A, I made an unordered map of column to value. So that way I didn't have to iterate through it each time with like a get. Every time I wanted to calculate the dot product, I just like calculated it once to make the unordered map, and then I would call the at of the map to get that to multiply each
Wait,
value in the B matrix.
sorry, did you use a map to to represent the matrix?
To represent each row of A, of matrix A. But I mean, in the end, like I discarded that because like it was only able to pass the small matrix test. To get to the medium and the large matrix test cases, you do end up having to use the iterators rather than like every row, every column.
Wait, so I am doing that, but the thing is that, see, I tried a few different things, right? I tried like I tried storing in a map first, and then like I also tried the matrix, but both of them didn't work. But like I in all of them, and also I just regularly try using one iterator for the A rows and then one iterator for the B rows. Is that what you did, or did you use different kind of iterators?
Yeah, well, those are the only iterators sort of necessarily available to you that would be the most efficient. Because it's just per list, right?
Right.
So
And
you're
then
just
you,
iterating through the nodes.
I see. But you still have a third loop, right? Where you like still have to go through each different one as it like moves.
Let me look back at it.
Do you guys know how to actually declare an iterator in the matrix algorithm class?
I do
Because
auto.
you're
Yeah,
using
me
auto
too.
and that works.
Yeah, you just use auto equal to a dot or like okay, it's like you can use auto to like basically like take the type name of anything. So like you can be like auto some variable equal to it, and then you can do whatever it is to begin, because then the C++ will be like dot begin return some kind of vector, right? Or like vector iterator. And so you don't have to do all like the
Right.
type name vector iterator stuff. You just put auto at the beginning.
Yeah, because I was trying like list and then the bracket with the sparse matrix dot dot node, and that doesn't work. And I was like, I think I tried playing with auto and then I couldn't get it working with that too. But if you guys are using that, I'll mess with this some more.
Sometimes you have to prefix it with type name. So there's like some ambiguity I was reading about.
Right, right.
And sometimes you have to like prefix type name so it knows that you're looking for a type rather than like a member, because like the colon is ambiguous, something like that.
Right.
So sometimes you have to throw that in.
Hey, Denny, so I guess maybe like for the first two loops, I think maybe I'm on the right track. But on the third loop, are you using an iterator, or are you just going for like the number of columns?
So my outermost loop is just it's just every row of column A, which makes sense, right? That's
Every
what you
row,
always start with your dot
wait,
product. And then
every
my
row of
two,
column,
go ahead.
I'm just trying to understand. Every row of column
Yeah, so it's not iterators. It's just I'm literally just going down the spine of the matrix. So it's I'm getting every single row of A. So I'm basically just going through the whole vector because it's a vector of a list, right?
Yeah, right.
So I'm just going through every list.
I see. So like so in the first one, you're iterating over the under or like the rows member data, and then the second one, you're iterating over B's rows, right?
My second, for both of my inner loops, I'm using iterators. So my first inner loop, I'm going through the iterators of each, because first I'm going through each row of A, right? And that's just gonna that's just basically gonna be your n in terms of like matrix dimension. But then afterwards, instead of iterating through every single column, I'm just using iterators to go through any non-default value held in the list. And then it's the same thing with the innermost loop. I'm only getting every single non-default value of B.
Oh, so in the first two loops, you're only iterating over A.
Yes.
Oh. Oh, you know what? I think that might be the issue with mine, because you know what I was doing? I was iterating in the first loop over A and the second loop over B. And then I was in the third loop, like doing the matrix multiplication where I move one column, one row down, one column, one row down. But what you're saying makes sense because you don't have to do that. It does it for you, because if you just get the first row of A, then the row currently in B, and then inside that you just, so you're saying like you have an iterator over first rows in A, and then you have an iterator over all of the elements in A's rows, and then inside that you have an iterator over all of B's.
Mm-hmm. Yeah.
That makes sense. I think that's
Yeah.
my
The
problem.
tricky part was just trying to figure out how to get the dot product to work for that like last innermost loop. And that's where I started using add to cell, because in regular matrix multiplication, like you can just assume that like once you transpose, like you're pairing up each of the products and then you're just like adding them all together. But in this case, like you may not have a non-default value in the same row where of B where there was a non-default value in the columns of A for that corresponding row, so then that's why you have to use add to cell to like come back to it later if needed.
Oh, so in your innermost loop, okay, maybe I'm misunderstanding what add to cell is supposed to do. I thought add to cell just adds the value onto like into the cell. Like if it was like 10 and it's add to cell ij of 5, then it would just make it 15.
Mm-hmm.
Is that
Yeah, correct.
that's correct? Are you calling dot get inside the inner loop? Because I was thinking that might be my issue.
Get. Yeah, I'm calling both. I'm calling the get call as well as get val.
Wait, get call and get. No, I mean like, are you
The sparse matrix get?
Oh, the one where it iterates through each one?
Yeah,
No, I'm not.
you're not one of them. Did you pass the large sparse matrix test,
Yes.
Denny? You passed it?
Mhm.
Oh, okay.
you know what? I think I just realized what I was doing wrong. For some reason, I was iterating over all the values, but instead of just doing the get val, I was for some reason using some like indices arithmetic to call dot get. like just to dot get meta on the sparse matrix. But I think that's like a totally inefficient operation because you can just do dot get val, and that would just get you the value instead of having to go iterate through everything again.
Yeah. That's just how, like, once you kind of get like the whole dot product thing, it just sort of clicks. It just took a long time for me to click, like, but once you get it, I think it just it's like, oh, there you go. Yeah.
I see. All right. Thank you for your help. Good discussion.
Is there a guideline on how long these meetings should be? It's just like however long we need them to be able
Yeah.
to.
Yeah, pretty much. You haven't taken a NANS classes before, Danny?
No, I skipped over A because I took an intro to programming class like years ago. And I took B with Professor McKell in the spring. Yeah, and then I just when Professor Nan sent out like the emails like maybe start looking at the quests if you've never done my questing system before. I did it like maybe a month before class started. Just went through
Yeah.
what was it? Green and blue.
Yeah.
Yeah.
Wait, so Denny, I'm thinking about what you just said. So in what you just said, you wouldn't be doing the entire both row and A and column moving at the same pace, right? In what you're saying, they won't be moving at the same pace.
Correct. Yeah.
Uh,
Because they like that's how you would think in like normal matrix multiplication, but in the sparse, like you could still do it, but if you're only trying to use the iterators, then it's never necessarily true that like you'll find, because you know you're for each row of A, you're going through and you're taking the columns, right?
right.
And this
Yeah.
is like column like 399, 500, and
Yeah.
they may not necessarily, once you transpose that, they column B, like row 3, row 129, and row 500 may not necessarily have non-default values. And so normally you would just like before I was just like I kept on adding to my dot product like iteratively as I went through each thing, but you can't do that necessarily in this case because you can't just assume that there's like going to be a node there.
Right. Right. Because like, yeah, because if you do that, then it's not necessarily going to be like a column a column 100 and row 100. It could be like column 100 and row like 5,000 or something. I don't know.
Yeah.
Right. Or maybe the other way around. But yeah. Makes sense. All right.
Did anybody get the textbook for the class?
I have a PDF of it.
Oh, okay.
The one by Weiss, right?
Yeah, just the
Weiss.
one that was in the recommended syllabus. Like I know Professor Anon pointed us to Losif's old modules. So I've only been going through those, but I was just wondering
Yeah,
if anybody had the book, if it
I feel
was
like
like,
that's pretty much all you really need for the class.
yeah,
I
it's
mean, I
been
haven't
pretty
really
good.
I've referenced the text like a bit just to learn more about the topics, but
Okay.
yeah, it's kind of it's a pretty like it's not like a real intro friendly text. It kind
Hmm,
of talks about higher concepts and stuff like, so it's
sure.
like I don't really want to just like jump around and read stuff on the, I wish like he kind of just gave us like hey, read this chapter for this quest and stuff, so like kind of know what he expects us to know.
Uh-huh.
Yeah.
Yeah.
Yeah. And it's kind of the same with the LOSEF modules as well, right? Like they don't follow the quests 100%.
Yeah,
Yeah.
not like a true one-to-one mapping, but
Yeah. So
it's pretty close, I think.
yeah.
We're mostly going in the same order. Um,
Yeah,
okay,
I
that's good
think
to know.
this 2C it follows it much better than 2B did. Because 2B there's like some weeks are like in the LOSEF modules, it's like completely irrelevant to whatever quest we were supposed to be doing that week.
Okay.
Yeah.
Which do you guys feel the hardest CS2V quest was for you?
I think 4, the one where we introduced the tree.
Mine was 3.
The koala quest. Yeah.
The koala quest. Was that the
That was the tree, the child sibling tree. I
Oh,
think
okay.
I think right, because the other tree we did was the try, right? Right.
Yeah.
Right. Yeah.
Mhm.
And yeah, the child sibling tree, the first one we, because I mean that was pretty new to me. So it took me a while for that
I
to
think
get going.
conceptually that
Yeah.
one, like I couldn't figure that out without reading Losef's module. Because like Anon gave in his spec, like, oh, like how can we make like the binary like left right like do the same thing for a general tree with the parent child, and I couldn't see it without having to read through first. That was a really weird one conceptually. Yeah,
Yeah.
I would say it was the Tower of Hanoi with the caching one for me. Like, I think that was the only quest where like I just got the password and I moved on. I was like,
Yeah.
I'm not gonna try to like get this cache
Yeah.
situation.
I never even attempted that memoization. I kind of feel bad because I feel like that's kind of important to actually like understand how to do that, right?
Yeah.
But I never really even attempted it. Like I just got the password and moved on with that as well.
Hmm. Yeah. It's pretty cool though. A lot of Anon's quests are like, yeah, they're a lot of fun. Um, it's like it just takes a lot to try to get through.
By the way, the freeze date for quest 2 is or quest 3 is when?
I think it's next Monday. So I think quest 2 is tomorrow.
All right. And also, like, if you
Yeah.
don't get all the trophies for one of the quests, is it like let's say you got like you need to get 3 more trophies to get all of them, but then the freeze day happens, so then you can't get more trophies on that until you finish quest 9, right?
That's my understanding of it. Yeah.
Okay.
Yeah. But I don't know. I'm not sure if it seems like super strict.
Yeah, I don't think he's super strict on it. I'm pretty sure that's the policy, but you see, like when he imports the grades, like they're not on
Yeah,
the freeze date. So I don't know if he checks it like up to the like he
yeah.
actually has a check on the date of when you last submitted it. Because on
Like he
the
just imported my grades
yeah, because
Yeah.
like
when you
a couple
check
days
when you
ago.
check the trophy site, you'll see the last date submitted and everything, right? The date and time of your submission. But so he can like check that, but I don't know if he does.
Yeah, not sure. But I mean, I guess the best way to do it is just to finish quest 9 and then just have a go at all of our previous quests. And then the hope is that by the time you reach that point, you'll have reached the cap as well. So, you may not necessarily need to.
Hey, by the way, for that, I'm asking you a lot of questions, but when like for that last inner loop, like I'm just thinking about it intuitively. Like I'm just trying to figure out how that works. If you're iterating over all of B's rows, right? Wouldn't you have, or like, wouldn't you have to switch to the next to the next one eventually. Like, let's say I'm on for A, I'm on row 0 right now. And for B, I start on like I'm iterating to all of B's rows, right? But like, wouldn't I have to iterate then on each of B's rows as elements?
Yeah, so I'm not actually iterating through each of these rows. I'm only iterating through each of these elements. And again, the reason you don't have to iterate through each of these rows one by one is because of the definition of the dot product, right? You know which rows of B you need to access because you get them from the columns of A.
Or the, oh yeah.
Yeah, so because you know the columns of the non-default values of A that you're already iterating through, then by nature of that, you also know what rows of B you want to access as well. Given that you can assume that the default value is 0, so anything else would just zero out in terms of that portion of the dot product.
But I'm confused about about okay, wait, so you get let's say some value of the first of A's column, right? Let's say A's column currently is like, or like the get call on A is like 50. Then on sorry, I think my ringer is on. Yeah, 1 second. Okay, so like then when you're iterating, then wait,
Then you know you have to get row 50 of B, right?
but how do you know which column of B you have to use?
You use all of them because you're using you're iterating through each node.
Yeah, 1 second, sorry. Sorry. So you're iterating over each of A's, the current row of A's is of values, and you get that column. But then when you iterate, or like you had to get the corresponding value of B, right?
Right, uh-huh.
But then wouldn't you need 2 indices for that?
I'm not quite sure I follow your mental map.
All right, so like, let's say I have A, right? Matrix A, sparse matrix A. And on A, first one is iterating over all of the rows of A, right? And then the second loop that I'm going to use like iterates over every value in the current row of A. Then next, so like then I have every value of the current row of A, which is like that row's columns, right?
Mhm.
Right. Then on the next loop, well, I need to get the value of B, right? That corresponds with that row's column in A.
Right.
But how would I do that? Oh wait, would I just iterate over only that's, oh, maybe I just iterate over that specific column in B, right? So I just get the value of the current column in A is, so I'm on, let's say I'm on row I, or like just row I column J in A. Row I column J in A. I'm just confused on how would I like?
I think you're almost there. This is exactly where I was before I could pass the large test case. It's like once you kind of stare at the dot product definition long enough, and you just kind of like also work out how to use add to cell, it'll just click.
I see. My confusion is like in matrix multiplication, you would have to go through each of the columns of the row. But I guess in this case, you don't have to do that because you already have because you already have the value of A. But I'm just confused. I'm just confused then like matrix multiplication doesn't really work in that case, right? Like you're using a wholly different algorithm.
Mm-hmm.
Okay.
Yeah.
Yeah, I'll think about it then. I'll think about that because I think I just maybe just need to try it out myself.
Yeah. I think you're almost there.
Thank you.
So I think assignment or quest 2 is frozen tomorrow, right? And I think Adam said you're still working on it, right? Do you need any help, or should we just kind of call it early so that we can just get back to
Yeah, no,
questing?
I'm good. Good. Yeah, the only thing I was gonna say, I'll make a post on Reddit, but there's a good data algorithms course book that I read that's because I agree, a lot of the data structure books are pretty tough to read. As a good class that covered some of this material, and it was like the standard textbook and it was brutal. So I found a good one that's in Python, and it's like a
Oh,
really
nice.
good, just kind of like gives you a sense of just like why these things are important in the first place.
Right.
So
Yeah.
so
Kind of focus on the algorithm versus like the complexities of the C++ language.
that, and then also if you go right to the math, in my
Okay.
experience, like the mathematical abstractions, are kind of driven by like actual problems. And, if a lot of these books like just present the mathematical abstractions, and at least for me, it was just too hard to connect at times. So I'll post the book, but it's like, I think it's like a common
Nice.
sense guide to data structures or something like that. But like
Okay.
if I found it
That's
online,
great.
it's but yeah, but just if you are just in like self-study, you know, these books could just be like so brutal,
Yeah. That
because a lot
sounds
of them
good.
act as like references, so they want to have proofs and they want to have like, but yeah, I did find one book that was like, actually kind of got to the point.
Oh, sweet. I'm always
So
like looking for those kind of recommendations. Just kind of like easier to read textbooks that get the point across.
yeah, I mean,
I'll
I
look forward
basically
to
worked.
that post.
Okay, cool. Yeah, I mean, I basically worked through the book without any additional help. It was pretty straightforward.
Nice.
So, but I was saying it's also East Coast where I am right now. So
Oh, it's
late. So
already like midnight for you.
yeah, exactly.
Oh, shoot. All
Yeah, there's
right.
no worries, but
Motion to end
yeah,
the
exactly.
meeting and get
Exactly.
back to
Yep.
questing. Gotta get quest 2 in, right, Adam?
Yeah, hopefully we'll see.
All right. Well, I'll be on Reddit tonight, just still working through questing. So if anything, just like post away and we'll see if we can comment quick enough.
Right on. Right on. Thanks,
Is there
guys.
anything, do you feel like you're stuck anywhere for quest 2?
No, I just had a super busy week. So
Okay.
I cracked it today and I was like, okay, I think I see how this works a little bit, but C++ is always like crazy stuff to learn. So it's like, what's the friend do here? Why don't I call it friend member? So it's always more things trip me up always, but we'll see.
All right.
All right. All right. See you guys.
All right,
See you
guys.
guys.
See you later.
Have a good one.